Algebra 2, Unit 6, Lesson 16 is called Features of Trigonometric Graphs, Part 2. Okay, the first one says, which one does not belong? You can come up with a reason for all of them. Let's see here. This first one here, I would maybe say this is the only one. If you look at the x-axis, it's the only one without pi. On x-axis. I would say maybe B is the only function without any transformations. Okay, because you can tell this since it starts here, amplitude's 1, period length is 2 pi. You can say this is y equals sine of theta. So no vertical shift, no horizontal shift, no amplitude. C, you could say it's the only one with a period length greater than 2 pi. You look there, your period length is 4 pi. Only graph with period greater than 2 pi. Okay. And then D, you could maybe say, because I start up here at the maximum, this is, actually, I would be wrong on B. This is just y equals cosine theta. So maybe this is the only function that is cosine function. I might have to change my reason for B now. B would be a good reason for B. The only function, I don't know, would be a good reason for B. But anyways, there's some reasons for A, B, or A, C, and D. All right, for each graph of a trig function, identify the period. So you need a full cycle. So this one has a period of 1. If I go over here, this one has a period of 2. If I go over here to C, start at the top, so I need to end at the top. Period length is 2 over 4. I don't know why they write it 2 over 4. It should just make it 1/2. And then on the last one, that period is 2 over 3. Now, I also want to show you, I started from 0. On all of these, what you're basically doing is you're taking this value farthest to the right minus this value, which is 0 here. It's basically 2/3 minus 0 gives me the 2/3. You could pick any other part on the graph. Like, let's say I started here and did a full cycle. This would be same thing, 5/3 minus 1, which would be 5/3 minus 3/3. It gives me the same value, 2/3. Okay, so it doesn't have to start right at the y-axis. It can be any full period on the graph. Okay, you'll get the same value. All right, same thing up. Well, I'd have to use. I couldn't use B, but let's say I wanted to use, this part here for this function. Well, what's this length? What's the length from here to here? Well, 2 minus 1 is 1. It's the same thing, okay? All right. Here's some functions. Find the period for each function. So your period is equal to 2 pi over b. All right, you need to know that formula. Or I guess you could say your period is equal to 2 pi times 1 over b. Either way. So b is the number in front of the angle. Okay, so if I have y equals sine of b theta, b is the number right in front of your angle. Or if it's x instead of theta, it's still the value in front. So in here, my b is the 1 in front of the theta, so it's just 2 pi over 1. So that one's 2 pi. My b here is the 3, so it's 2 pi over 3. My b here is the 6, 10 and 1/3 there, so this is going to be 2 pi over 6. Let's reduce it to pi over 3. 2 pi over 10. Let's reduce that to pi over 5. And this one, 2 pi over 1/3. We got to multiply by reciprocal. 2 pi times 3 over 1. So I get 6 pi. All right, so make sure that you know this formula right here. This is pretty much the same thing. It's just now cosine instead, or it's actually, well, we had a couple cosines up there. It just has a pi though, right here instead of a whole number. So, same formula. 2 pi over pi, and then your pi's cancel, so it's just 2. Your period length is 2 radians. Okay. All right. Identify a possible equation for the trig function with this graph. Okay, so I start up here at a maximum, so I'm going to probably use a cosine, and I'm going to use theta for my variable because it's labeled on the x-axis, and I use y for my other variable. Amplitude is 1, right, from here to here, so 1 cosine. Let's find our period length. So my period length is 1. So I'm going to go back to that formula, P equals 2 pi over B. 1 goes in for period length, and now I got to find B. So if I know one out of these two, with P and B, I can solve for the other one. I'm going to get that out of the denominator. B times 1 is B. So B equals 2 pi. So it's going to be 2 pi times theta. My midline is at 0, so I don't need to put like a number here. You could put plus 0, but I don't need it. I really don't need the 1. And that would be good enough for me. Okay. Now you could do a sine curve and do a translation, but it's definitely much easier to just write it without doing a horizontal translation. Okay. Next thing, talk about the world's tallest Ferris wheel. Here's my function. Time is measured in minutes after 8 a.m. Height is in feet. What's the diameter of the Ferris wheel? So the diameter, think about this here. This is my amplitude, the 260. So that means I go up 260 and down 260. Okay, so my midline right here, like I go 260 from here to here. So this would be at the top of the Ferris wheel. You're at the highest point possible. And then 260 down here. This would be down at the bottom of the Ferris wheel. So obviously your diameter would be double your amplitude. It would be 520 feet, okay? Really, it's double your amplitude. Okay, your amplitude is the number in front of your trig function, okay? How long does it take the Ferris wheel to make a complete revolution? So we're looking for the period length here. We're looking for how long it takes to do a full revolution. So we're looking for period length. Okay, so P equals 2 pi over B. I know B is really it's 2 pi times 30, because if you think of this here, it's like 2 pi over 30 times T. They just put the T up in the top. So my period length is going to be 2 pi divided by 2 pi over 30. So it's going to be 2 pi. I'm going to flip this. And then what happens really nicely there, my 2 pi's cancel, so my period length is 30. That's t is the x-axis, so that's in minutes. So the answer is 30 minutes. Okay. Give at least three different times when the passenger seat modeled by F is at its lowest point. So the lowest point would be, let me think here. All right, so give at least three different times when a passenger seat modeled by F is at its lowest point. So since it's a sine curve, let me go up here. Let me rewrite the function here. Y equals 275 plus 260 sine of 2 pi t over 30. Since it's a sine curve, we know that it's going to, and it's not shifting, we know it's really basically starting here in the middle. Then it's going to go up to the top. Well, actually, hold on. My midline's way up here at 275. So we're going to start right here, and then we're going to go up another 260, back to the middle, down 260 to the bottom, and then finish. And this all ends in 30 seconds. So if I cut this into quarters here, it's like I slice my graph here into 4 sections. 30 divided by 4 would be 7.5 seconds. So it would basically take me 7.5 seconds to get to the top and bottom. Or top, middle, back to bottom, back to middle. So right here, this was 30. This is 7.5. This would be 15. This would be 22.5, and then to 30. So basically at 22.5, and then you could just keep adding 30, because then you're going to do the whole thing again. You're going to end up here. This is going to be a full period here. From here to here is 30. So it's going to be 52.5, 82.5, and so forth. Okay. So you got to kind of sketch that out a little bit. Sketch a graph of the height of the seat on the Ferris wheel for at least 2 full revolutions. I kind of did that there, but I'll make it a little bit neater here. I'm going to draw my midline right up here. That is at 275. I got to go 260. I start right there. This is going to be at 7.5, 15, 22.5, 30. So this goes up another 260. So I got to do 275 plus 260. This is up here at 535. 275 minus 260 is 15. So down here at 15. This comes back to 0 right there. So my graph will look like this. And then if I want to keep going, because it did say to do 2 full. This is going to go back up, back to the middle, down to the bottom, back to the middle. All right, and Not bad, a little rough there. So I'm trying to get through it as quick as I can for you guys, but take your time, use a straight edge, graph paper if possible. All right, so how does the graph of f of theta equals sine of theta minus 5 plus 2 compare to the graph of g of theta equals sine of theta? So this is my base function. This minus 5 here means it's going to be a horizontal shift or translation, right 5. And then this plus 2 means my midline shifts up 2. So it's at y equals 2. So it's a vertical shift up 2, okay? Or if you want to use the word translation instead of shift, that would be fine too. All right, so we go on to the next one. This 2 means your amplitude is 2, whereas this one here, amplitude is 1. Minus 5 means my midline is y equals negative 5. So that's a vertical shift down 5 for the whole graph, not just the midline, the whole graph. Go here, amplitude equals 5. And then your period length, 2 pi over 2, my period length is pi. So amplitude here is 1, and my period equals 2 pi. So I would say my period is double. I'm sorry, not double, it's half. And my amplitude is 5 times greater. And then over here, same thing with my amplitude. Amplitude is 5 versus my amplitude here is 1. So 5 times greater. My period here is 2 pi. My period here is 2 pi over 2 pi. So that'd be my period is 1. So, remember, it's not half of it because 2 pi is really like 6.28. So if my period is 1, it's like much, much shorter than 2 pi. So my amplitude's 5 times, and we have a much shorter period. Okay. Height in feet of a seat on a Ferris wheel is given by this function there. Time t is measured in minutes since the Ferris wheel started. What's the diameter? So it's going to be double the amplitude. So diameter 100 feet. Okay, because when you're at the center, you go 50 up to the top, and you come back to the center, and you go 50 down. So this is the bottom, this is the top, 50 to get to there, and then another 50 to get to here. How high is the center of the Ferris wheel? So the center is going to be right here. That's my midline. My midline is 60. So 60 feet. For the center. How long does it take for the Ferris wheel to make one full revolution? So we need our period length. So period equals 2 pi over b. 2 pi, let me go back up to the function. 2 pi over, this is my b, my value right in front of my angle, my variable. In this case, it's t for time. So I already forgot it. It was 2 pi over 10. So 2 pi over 2 pi over 10. So 2 pi times 10 over 2 pi cancels those, so I just get 10 for my period. And my unit was, I believe it was minutes, feet, and time is in minutes. So yeah. Right.